Uh, Thank you for giving me this opportunity. My name is Asoh. I'm a project manager of LUPEX project team of JAXA, Japanese Space Aerospace Exploration Agency. So today, my objective is to explain the ISRO JAXA collaborative mission in the future on landing Lunar South Pole landing mission. So okay. Yep. So first of all, let me explain that Japanese government decision or activities, because I will explain later on now, but ISRO and JAXA has an agreement to conduct a conceptual design study on LUPEX. This is a lunar exploration mission in 2017. But 2 years after that, Japanese government decided in their strategic headquarters for national space policy. This is a very high level committee in Japan. In 2019, so two years after that, the Japanese government officially decided to join the international space exploration, which will be called Artemis program after that. But at that moment, we call it international space exploration. 2019, and after that, Japanese government participate in Gateway MOU and made a signature of Artemis Accords. And last year, the Japanese government made a agreement with the American US government about the Gateway. Gateway is manned space station orbiting the moon. And also this year, the JAXA selected the new astronaut candidates. Mainly, main purpose of this decision, this selection, is to train the astronauts for the moon activity. So, in that time, the Japanese government decided the 4 items of cooperation that directly contribute to the moon exploration. And one of them, first one and the second one, is the contribution to the Gateway, the space station's contribution. And number 4 is Japan will provide the pressurized manned rover on the moon. And the third one, this is a kind of a data sharing for the selection of the landing sites and so on. So our LUPEX rover can contribute can obtain the data to contribute the Artemis program. So Japan's government decided to approve our LUPEX mission. So this chart shows JAXA's roadmap for lunar exploration. Year of 20s and 30s and the 40s. And we have already sent our satellite Kaguya to the lunar orbit, and Kaguya conducted many missions to observe the lunar data and so on. And last year, we have two payloads onto NASA's SLS-1, Artemis-1 mission. And also this year, I will explain later in detail, but this year we have a SLIM. This is a pinpoint landing technology demonstration mission. And next one is our LUPEX, Lunar Polar Exploration Mission with the cooperation is ISRO, and also NASA and ESA will install some mission instruments into the rover. And in addition to the LUPEX, we have a gateway, and also we have a study, just a feasibility study on the communication and navigation system on Moon. And also we have a feasibility study for mid-size lander to the Moon, and also a manned pressurized rover itself. So we will now we are studying about those missions targeting the late or in very end of the 20s and beginning of 2030s. And for 2040, we will conduct the sustainable exploration on the Moon, and also we will have some technology demonstration on ISRO technology. Okay. And I think some of you knows about ISECG. This is International Space Exploration Coordination Group. And this chart is derived from this ISECG report. And that report says International Lunar Surface Exploration Scenario. And you can see the many CLIPS, the US CLIPS mission, and China Chang'e, and also Japanese SLIM, and US Viper, and of course the Chandrayaan-3. And after Chandrayaan-3, Viper, and SLIM, we will conduct the launch of the LUPEX. So the LUPEX is one of the ISECG one of the mission which ISECG introduced. Okay. And as I said before, this is two upcoming JAXA's mission to the Moon. So one of them is the SLIM, pinpoint landing technology demonstration, and we have this SLIM is now scheduled for this summer, so very coming soon. And this is also TBD, but the next SLIM, we have a plan to develop LUPEX. The water. This is the objectives of the LUPEX is water prospecting at South Pole. And as I said before, this is a collaboration with ISRO, and I will explain later on in detail. But ISRO will provide a lander and instruments, mission instruments to the rover, and also NASA has a plan to provide the instruments, and ESA also. So that's international cooperation mission, mainly between ISRO and JAXA. I'm sorry, this is a little bit busy charts, but this table shows mission requirements to project objects. So we have a mission objectives at the higher level, and we down break down to the mission requirements, project goals, and project objectives. And in the results from the ISRO JAXA mission definition concept review, we have these 7 project objectives from A to G. And the first 3 is the so-called ISRO JAXA common objectives. So the first one is to obtain the ground truth data regarding the quality and distribution of water. So distribution means distribution in the horizontal direction and distribution on the depth of the depth of direction. So that means we can make water map on our landing site. This is the first one, and the second common objective is to obtain the status and forms of water. That means how easy to retrieve the water from the regolith. So that's the second one. And third one is that this needs to international cooperation, wider international cooperation, but to obtain the data relations between the water content and geological and physical conditions. So that means if our LUPEX goes at one landing site and acquiring the data, and we analysis those data, but just one rover is not enough to study those relations between water content and geological conditions. So we need a worldwide cooperation with Viper and other rover to prospect the water resources. And D and E is ISRO unique objectives. It is a part of a duplicated with Chandrayaan-3, but this one is very important things. And F and G is a JAXA unique objectives. This is just to demonstrate the technology of lunar surface mobility. JAXA has no experience to move on the lunar surface and acquire the regolith sample from the ground on the moon. So this is just very important objectives for us, for JAXA. And also the last one is that very important things, long duration stays, during the night. So this is very challenging objectives for JAXA. So those 7 are the contribution, mission objectives. So LUPEX spacecraft overview, this is just a conceptual, so very tentative one. But we will use the launch vehicle of H3. This is a Japanese next generation launch vehicle. And insertion orbit is not decided yet, but we guess that the similar one to Kaguya's one. And landing is expected approximately 1 month after launch. It is very similar to Chandrayaan-2 or 3. And total payload mass is about 6 tons, and rover mass is this is a tentative value, but 350 kilogram. And the mission duration now is 3.5 months after landing for nominal. But if the rover is very healthy, then we want to extend our mission duration to 1 year. So the table right-hand side shows mission instruments sensors, and there are many mission sensors, and one of them is radar. I will explain later on. And radar consists of ISEP, sample analysis package. And ALICE, this is advanced lunar imaging spectrometer, which is developed by JAXA. I will explain later. And neutron spectrometer will be provided by NASA, and GPR and MIR, and Pratima. It is under coordination, but ISRO will provide those GPR, MIR, Pratima, and ISOP. And this used to be a system sensor, but in the middle of our study, the EMSL, exospheric mass spectrometer for LUPEX ESML is considered as a mission instrument. So I will show you a video of LUPEX. This is just 100 times per actual speed, but we will go to predefined waypoint after we land. And I'm sorry, maybe my PC's capability is not so good, but using the GPR, ISRO's GPR, we located the water location in 1 meter depth or deeper. And once we decided to drilling point, then we drill up to 1.5 meter and acquire the regolith to our radar system. And sample regolith is taken by radar container, and we measured the mass of the regolith and then heat the regolith. Then we can know that mass is decreased, which temperature. So we can identify the water in some. The other sensor can help. This what is this? What we observed is the water or not. Okay, so two of I will explain the two of JAXA's developed sensor, mission instruments. The first one is resource investigation water analyzer, which is called a radar. And this is a integrated package. Consists of 4 sensors, and its radar includes the thermogravimetric analyzer. This to measure the mass of the regolith after heating, and also the radar consists of trace moisture. Radar has a capability to trace the moisture analysis. And radar has those 4 functions. One of them is quantifying the content of volatile components, and second one, measuring the molecular species contained in the volatile gas. Third one, measuring the water concentration in the volatile gas. And the last one is measuring the hydrogen isotopic ratio. So this is a very complicated and huge mission instruments, but now we have passed the preliminary design review and preparing for engineering model manufacturing. And the second mission instrument, which is developed by JAXA, is ALIS, the Advanced Lunar Imaging Spectrometer. This imaging of spectral brightness in the near infrared range enables identifying the location and measuring quantity of water ice on the surface. And identify the mineralogy of regolith or rock that is hosting water ice. So this is our second one. So this is a collaboration, international collaboration scheme again. So JAXA is responsible for a launch vehicle and a rover system and mission instruments and Gran network. And also ISRO is responsible for a lander system and mission instruments and Gran networks. And NASA and ESA will attend, and they will provide mission instruments and also support from the ground network. ESA also saying. So maybe 3 minutes are remaining, maybe. There are many universities and research institutes in Japan participate in this LUPEX mission. So not only JAXA, but also some University of Tokyo and other many universities and institute attending. So LUPEX Development Log. As I said before, the pre-phase A implementing arrangement with ISRO, JAXA, between ISRO and JAXA is concluded to study the possibility of joint lunar polar exploration mission. This is a 2017. And JAXA will go to phase B. The LUPEX project team has been established the last March. And we also pass through the project approval by Japanese government in July. And Reiwa and Alice passed the preliminary design review last month and last year, and this January this year. And now we are here, and we will conduct a rover and ground system PDR in around May. Okay. And I think last chart. Since JAXA, this is a development status of the JAXA LUPEX. And since JAXA LUPEX, we have those 8 activities, the preliminary design of the rover and ground systems, and also we are conducting the rover BBM testing, and Reiwa and ALIS PDR, as I mentioned before. And ESA-JAXA MOU has been concluded last year, and also technical coordination with ISRO, NASA, and ESA conducted. Also, within Japan, we have many collaboration with the scientific community. We call it ODCT, and also we studying on the landing site down selection methods, and now coordinating with ISRO, not only with ISRO but also NASA and ESA. So this is an outcome of the LUPEX. If we identify or conclude that there are sufficient water on the moon, then this kind of a world waiting for us. So we have many cooperative study with Japanese industries to build, to explore, to live, and to create the energy on the moon. Okay, thank you very much for attention. This LUPEX latest status is introduced in Twitter, this account, and also please see the LUPEX website, QR code there. So thank you very much.
Yes, thank you. Thank you very much. On the 2 slides back, you showed and I think I saw in the movie also, yes, the kind of tank-like tracks. Yes, like, and then the right lower picture. But then in the left lower picture, I see these wheels. Is that just another option that at some point was down to the tracks, or is it something else?
I see. Good question. This is a BBM for drilling and acquiring the regolith. So our current design in the PDR phase is like this. It's a Crawler type one. In the past, it is one option, but now.
And can you be very quickly say why? What was wrong with the wheels, or why do you prefer the other? Is it quick to say that, or is it difficult to say that?
It is very difficult and complicated, but the first easy reason is to climb up and climb down at around 25 degrees slope. 25, yeah, correct.
Other questions? Okay, if there are no questions, let's thank speaker once again.
Okay. Thank you very much. Thank you.